Hey guys, it's Pratik and you're watching Technocrat. When you look at the entire range of audio hardware, then the two most important audio equipment would be microphones and speakers. Microphones are used to record sound and speakers are used to make sound. Basically, both microphones and speakers are nothing but transducers. Transducers are devices that convert one form of energy to another form of energy. So, microphone is an equipment that would convert sound energy to electrical energy, and speakers are the equipment that would convert electrical energy to sound energy. The construction and the working principle of both microphone and speakers are very similar. They both work on the Faraday's law. Faraday's law states that when there is an electric current passing through a conductor, there would be a magnetic field. And similarly, when there is a magnetic field around a conductor, then there would also be an induced electric current. Now let's look at the construction and the working of a microphone and a speaker. A microphone or a speaker has a cone made of paper or a diaphragm. There is a magnet that is attached to this cone or diaphragm, and there is a coil which is coaxial to this magnet. In a speaker, when there is an electric current that is passing through this coil, it creates a magnetic field which interacts with the magnetic field of the magnet, and this interaction between the magnet and the electric field of the coil makes it oscillate. So the electric current that is passing through this electric coil directly is proportional to the amount of amplitude that the audio wave will have. In a microphone, when the sound wave that is need to be captured, the rarefactions and the compressions hit the diaphragm, then the magnet moves. This magnet creates an oscillating or a varying magnetic field in the plane of the coil, and it creates an electric current. This electric current is typically in millivolts, so that's why we need amplifiers which amplify it to range of volts. You can find two kinds of microphones, the passive type of microphones and the active type of microphones. The passive type of microphones don't need an external power supply. They have a diaphragm and a coil attached to it. These are also called as moving coil dynamic microphones. Whereas on the other hand, coming to the active kind of microphones, they do need an external power supply. They are also called as condenser microphones. Let's see how they work. Basically, a condenser is nothing but a capacitor. A capacitor is something that is used to condense charge. These microphones are also called as condenser microphones. In a condenser microphone, an external power supply is always used to put these two plates at a constant voltage, so there is a charge retained between the different plates of the conductor. These microphones are also called as condenser microphones. In these microphones, an external power supply is used to put the two plates of the condenser or the capacitor at a constant voltage, and thereby they are used to store charge. The capacitance of any capacitor depends on two factors: the area of the plates and the distance between these two plates. The condenser microphone is built in such a way that one plate of the capacitor is fixed to the body of the microphone, and the other plate of the capacitor is a very thin aluminium foil or a copper foil. In this way, when the sound wave hits this thin foil, the capacitance also varies. So the change in capacitor itself acts as the audio signal. If we compare the passive type of microphone and the active type of microphone, then the active type of microphone would definitely have a superior quality, because when you look at the transient response, the passive kind of microphone would take more time to settle down, whereas the active kind of microphone would not take that much time because it has a very thin foil. In a passive kind of microphone, the diaphragm would be heavy as well as the coil also. The tin foil in the condenser microphone would also be able to capture those minute details in sound, whereas the passive kind of microphone might not be able to because of the bulky nature of the diaphragm. The active kind of microphones or the condenser microphones are generally expensive than the passive kind of microphones, but they both have their applications. Like the passive kind of microphones or the moving coil microphones are used on stages, whereas the condenser microphones are used in studios. Even I am using a condenser microphone. In these condenser microphones, the external power supply is supplied through batteries in such kind of enclosures. Now let us see how a speaker works. It is just opposite to how a microphone works. When electric current is passing through the coil of the speaker, then it would create a magnetic field that interacts with the magnet, and then it would push the diaphragm to and fro, and this would create sound. The size of the microphone or the size of the diaphragm has a very interesting relationship with the frequencies that it's good at producing. So a speaker that is large in size would ideally be able to produce the frequencies which have a very low range. This is because the frequencies which are having a very low range are the ones which have very high wavelengths. So as the wavelength increases, even the size of the speaker has to increase. In a similar fashion, speakers that are of small size are good at producing very high frequency notes. When you go to purchase speakers for a public addressing system or a home theater, The specifications of speaker that you first get exposed to is the maximum power handling capacity and its impedance. So maximum power handling capacity is something like you get to hear like 1000 watts, 1200 watts and 800 watts. Maximum power handling capacity is nothing but the maximum power that your speaker system would be able to handle, and impedance is nothing but the resistance that it would provide to the power delivered by the drivers or the amplifiers. So most often you get to listen to power capacities of speakers like 1200 watts, 800 watts or sometimes 10,000 watts in a public addressing system, and you get to listen to impedance values like 6 ohms, 4 ohms and 8 ohms. So whenever you go to purchase a speaker, the salesperson would always tell you the power handling capacity, but I feel that sensitivity is one factor that you need to look at. So let's try to understand what is sensitivity. Sensitivity is the amount of loudness of sound that a speaker is able to produce when it is provided with 1 watt of power. So when you compare two speakers having lower sensitivity and higher sensitivity, then the speaker that is having higher sensitivity would take less amount of power to deliver the same amount of loudness. Typically, sensitivity is measured as the amount of loudness that is produced at 1 meter distance from the speaker when 1 watt of power is supplied to it. A low quality speaker would have sensitivity something around 87 to 90 decibel per meter per watt, and a high quality speaker would have sensitivity something around 93 decibels. Let me remind you that it might just seem to you as an increase in 6 decibel, but then when the decibel value increases by 10, then the amplitude increases by 100 times. This video is part of the series Understanding Audio. I've also made few other good videos like how audio jacks work, how noise cancellation works, what are the different kinds of file formats and how audio compression works. Do watch all of them if you want to have a better understanding of audio. Subscribe to Technocrat if you haven't yet subscribed, and do turn on the notifications to never miss an update. I'm glad that you wanted to learn something new today, and I hope you have learned something new from this video. Always believe in science and make the best possible use of technology. Thanks for watching. Bye bye.